So we'll start with this question. An airplane increases its speed from 100 meter to 160 meter at the average rate of 50 meter per second square. How much time does it take for the complete increase in speed? So we'll use this formula: v is equal to u plus 80 square, or just v is equal to u plus 80. So we have our final velocity, we have our initial velocity, and we have our acceleration. So we put all the values in the equation and we have to find t. So t is equal to 4 seconds. Our answer is A. Now let's move on to the second question. A plane flying horizontally at a speed of 50 meter per second and at an elevation of 160 meter drops a package. After 2 seconds it drops another package. Now how far will two packages land on the ground? So basically they're asking the distance between these two packages. This is the one package, this is the second package, and it's traveling horizontally with the speed of 50 meter per second. So we know distance is equal to speed times times. Speed is 50 meter per second and time is 2 seconds. Answer is 100 meter. C. Now we'll move on second question. An object has mass of 60 kg on Earth. What is the mass of object on the surface of the moon where acceleration due to gravity is only 1 by 6 of that Earth? So the mass is 60 kg. And acceleration due to gravity is only 1 by half of that Earth. And what is the mass on Earth, like on moon? So the mass of an object remains constant regardless of its location. The mass thus the mass of the object on the moon will be same as the mass on Earth. Even though the gravity on the moon is 1.6 times of the Earth, mass is not affected by the gravity, only weight is affected, and weight is mg, mass is just m. So our answer is C, as it is. Now let's move on the next question. A 10 kg mass is moving with a speed of 5 meter per second. How much work is required to stop the mass? So let's write our data first. Mass is equal to 10 kg, speed is equal to 5 meter per second, and they want us to find work done. For that, first we need to find kinetic energy of the object, which is half mv square. This is the equation of kinetic energy, and let's put our value. So half times mass times velocity square, it will give you 125 joule. So the total work done to require to stop this mass is, you have to stop the kinetic energy of this mass, because this mass is moving with the speed of 5 meter per second. So if you want to stop this mass, then you need this much energy, this much kinetic energy in order to stop this mass, but in the opposite direction. So our answer is 125 joule, C. Let's move on next question. So here I am covering only numerical questions. Theory based questions are, I'm skipping those questions. An object has a volume of 4 meter cube and weight of 40,000 Newton. What will be its weight in the water? So to find the weight of this object in the water, then we need this equation. Buoyant force is equal to rho times V times G. Now this is the density of water, this is the volume, and this is the gravity. Now let's find the buoyant force. So density of water is 1000, always 1000. Volume is given 4 in the meter, so you know you don't need to convert it into meter or centimeter, you can use it as it is. So it will give you 39200 Newton. Now apparent weight is equal to weight of object minus buoyant force. So 40,000 Newton minus 39,200 Newton will give you the actual force of the object in the water, apparent force. So this is our answer, B. Let's move on. Second question. Question number 37. So the wavelength in the air of sound waves of frequency 500 Hz is, so we know this general formula, lambda is equal to V upon F. V is the velocity, lambda is a wavelength, and this is frequency. Now what is the velocity of the sound wave in the air? So 343 meter per second. This is fixed value, and frequency is given in the question, which is 500 Hz. Now let's find our wavelength, because they are asking us to find wavelength in the water, no in the air. So it will be 343 by 500 will give you 0.686 meter. So our answer is C. When you round off this digit, it will become 0.69 meter. Let's move on. Next question. A roller coaster car with mass m is on the track that forms a circular loop with radius r in a vertical plane. If the car is to just maintain the contact with the track at the top of the loop, what is the minimum value of its speed at that point? So let's say we have this data. M is the mass of car, r is the radius of loop, v is always the velocity or the speed of the car, g should be the gravity. So now in this particular case we can say that force due to gravity is equal to force of centripetal acceleration. As it is in the vertical direction, so the only force of acceleration is acting on this system is gravity. So now we know F is equal to mg and centripetal acceleration is equal to F centripetal is equal to mv square by r. So we'll substitute the value of F centripetal here, mv square by r. This m will be cancel out from the both side, and now we have g is equal to v square by r. Now you rearrange this equation, then v is equal to g times r, v is equal to under root g times r. So yeah, our answer is under root g times r, A. 38. Yes, 38 answer A. Let's move on the next question. So next question said express 68 Fahrenheit in Celsius. So you just need to convert this into the Celsius. So we'll skip this question and we'll move on the next. So this is our next question. A motorist traveled for 3 hours at the speed of 80 km per hour and 2 hours at the speed of 100 km per hour. What is her average speed for the trip? Now this diagram is useless, like it's for second question. So for distance 1, he travels 80 km per hour for 3 hours. To find the distance 1, we just multiply the velocity times. So d is equal to speed times velocity, speed times times. So it will give you 240 km. So in the first part, when she drives 80 km per hour for 3 hours, the total distance covered by her is this. And for the second part, d2, 100 km per hour times 2 hours will give you 200 kilometers. So for second part, when she traveled with the speed of 100 kilometers per hour for 2 hours, she covered 200 kilometers of distance. Now total distance, you just need to add these two values, which is 440 kilometers. So this is the total distance traveled by the motorist. Now they want us to find average speed. So now once we had the total distance, and then we have to find the total time in order to find the average speed. So total time is 3 hours plus 2 hours. So total time is 3 hours plus 2 hours, total 5 hours. So average speed is equal to total distance upon total time. So this is our total distance, 440 upon total time, 5. So average speed will be 88 km per hour. This is our answer, 88 km per hour, C. Let's move on second question. Two forces are acting on an object as shown in the figure. So F1 is acting in this direction, F2 is acting in this direction, making angle of 60 degree with x-axis, positive x-axis, and making 75 degree angle with negative x-axis. Now what is the magnitude of the resultant force? So basically you just need to add F1 and F2 in order to find the resultant force. So let's do that. So F1 is equal to 120 Newton at 60 degree with positive x-axis. F2 is equal to 80 Newton at 75 degree with negative x-axis. Now we need to break down this both force into x component and y component. So F1 x component will be F1 cos theta. Now what is our theta? 60, because F1 is making angle of 60 degree with positive x-axis. So this is our F1. Now F1 is given 120, cos theta will be 60. So 120 times cos theta will give you 120 times 0.5, 60 Newton. So F1 x component is 60 Newton. Now F1 y component, which is F1 sin theta. Substitute the values. Sin 60 will get 103.9 Newton. So this is the y component of this force. Similarly, we'll do the same thing with F2. So x component of F2 will be F2 cos theta, 80 times cos 75 will give you 20.7 Newton. F2y will be F2 sine theta, 80 times sine 75. So sine 75 will be, it will give you some value and you have to calculate this, and you will get 77.3 Newton. Now you have to find the resultant force. So to find the resultant force, of x-axis, so f of x or fx is equal to f1x plus f2x, which is this and this, and you just have to add those values. 60 plus 20.7 will give you 80.7 Newton. Similarly, resultant force on y-axis, Fy is equal to F1y plus F2y. So F1y is 103.9 Newton, F2y is 77 Newton. When you add both this digit, you will get 181.2 Newton. Now resultant force, the formula for resultant force of two vectors or two force F1 and F2 will given by Fr is equal to f of x plus Fy whole square and whole under root. Now this is the addition of both the x component of this force, both the x component, and Fy is the addition of both the y component of that force. So let's substitute all the values. 80.7 whole square plus 181.2 whole square, 198.7 Newton. So this should be our answer. Let's see. 198, answer is A. And our answer for 42 is A. Alright, next move on the second question. So a projectile is launched at the angle of 30 degree to the horizontal with a speed of 30 meter per second. What is the horizontal component of its velocity after 2 seconds after the launch? So let's say something is thrown in the projectile motion. So this is the projectile motion with the angle of 30 degree and with the initial speed of 30 meter per second. and they want us to find the horizontal component of its velocity after 2 seconds. So for that, the horizontal component of the initial velocity will be u0x is equal to u0 cos theta, and the vertical component of initial velocity is u0y u0 sine theta. But we don't have to care about this because they didn't ask us to find anything about the vertical component, so we'll take care of this only. Now let's substitute our value. v0x is equal to 30 times cos 30 because this angle is given in the question, and it will give you 25.98 meter per second. So this is our answer, which is D. Let's move on to the next question. Three kg mass is positioned at this, and 1 kg mass is positioned at this. What are the coordinates of 4 kg mass which will result in the center of mass of the system of 3 masses being located at the origin? So they want us to find the center of mass, and what is the formula of center of mass? So center of mass of x component will be summation of all masses times x component divided by summation of all mass, and same for the y, summation of all mass times y divided by summation of all mass. As they said, center of mass is at origin, so we can say this equal to 0 and this equal to 0. So for x component our formula will become 0 equal to this, and for y component our formula will be 0 equal to this. Now we just have to substitute the value of our mass and x component, all the x component in this, and mass here, mass and all the y component. So let's do it. So for x, 0 equal to 3 times 0, 3 times 0 plus 1 times 12, 1 times 12 plus 4 times x plus 4 times, we need to find the coordinates, so 4 times x whole divided by the total mass, and total mass is 3 plus 4 plus 1, so this will give you minus 3. X is equal to minus 3 because you need to take this x on this side and you have to do some calculations. So now you'll know the x point on the graph. Similarly, you have to use this equation and find this center of mass, point of center of mass on the y-axis. So 3 times y component, which is 8. Yes, 3 times 8 plus 1 times 0 plus 4 times y. 3 times 8 plus 1 times 0 plus 4 times y whole divided by 8 total mass. This will give you y equal to minus 6. So this is our component, minus 3 minus 6. That's our answer, B. Minus 3 minus 6. Now let's move on the next question. How many number of water molecules are there in 36 gram of water? Express your answer in the multiple of Avogadro number Na. The molecular structure of water is H2O. So number of moles of water is equal to mass of water upon molar mass of water. Number of moles is equal to actual mass upon molar mass is equal to 36, which is given in the question, and 18 gram per mole. This is the molar mass of the water, so it will give you 2 moles. And how did you find this 18? H2O. So 2H plus O. O is 16, H is 1. So 1 plus 1 plus 16 will give you 18. Now, total number of molecules is equal to N times Na. So this will give you 2 Na. So this is your answer, 2 Na. Na is Avogadro number, so our answer is A. Let's verify our answer. Yes, it's A. Let's move on. Next question. As I have said before that I am not covering all the theoretical questions, I'm just covering all the numerical questions. So if you want theoretical questions, just drop a comment, or you can just ask me in the mail or email. So this is our next question. 15 kg bullet travel with the speed of 213 meter per second in a vertical direction. Bullet is trapped in 2 kg of block of wood and rest directly above it. As a result, bullet and block combined and move vertically upward. What is the maximum height reached by the bullet and the block? Let's say block is hanging on something and the weight of block is 2.4. Now bullet is coming in this direction from the below with a speed of 213 meter per second. Now after the collision, the whole block and the bullet system will move in this direction due to the kinetic energy this bullet possesses. Now they want us to find the total height reached by the bullet and block the combination. So it's basically they are asking us to find how much centimeter they will go upward in the direction after the collision. So we can say that our momentum is conserved. So we can say that m1 plus v1 m2 v2 before the collision is equal to m1 times v1 plus m2 times v2 after the collision. Before is equal to after. Now after the collision, our both object 1 and object 2 combined, so our v2 and v1 will become same, which is vf. So m1 plus m2 times vf. So this whole equation becomes this, and this is as it is. Now we'll substitute all the values given in the question. We need to convert this gram value into the kg, so it will become 0.015 kg times velocity. So this is the bullet velocity of bullet, plus 2.4 kg of block, and its initial velocity is 0, is equal to 0.015 plus 2.4 times vf. Now you have to find this vf. So by solving this all, you will get vf is equal to 1.323 meter per second. Now once you find the velocity after the collision, then you can find the distance after the collision. So you can say that all the kinetic energy of the bullet is converted into the potential energy. So like kinetic energy is the energy, or any object is moving in particular direction, it possesses some kinetic energy, or any object it's on some height from the ground, then it possesses some potential energy. Now we know potential energy is equal to gmh. This is the mass, height, and the gravity, and kinetic energy is equal to half mv square. So we'll substitute the equations. So in this case our kinetic energy will become half m1 plus m2 times vf square. Why m1 and m2? Because we need to take total mass of the object. So this is the total mass of combined bullet and the block. Now PE is also m1 plus m2 gh, the same total mass. Now this will be cancelled out. We have half f2 square vf square is equal to gh. Now you have to find this h. So h is equal to 0.5 vf square by g. Now we have to substitute all the values, which is 0.5 times, or just take 1.323 whole square divided by 2 times 9.8 will give you 8.9 centimeter. This is our answer. So our answer is A. Let's move on the second question, the next question. So in this question, a person jogs 8 complete laps around a quarter miles track in total time of 12.5 minutes. What is the average speed? Now, first for that we need to find the total distance covered by this person for the quarter miles for 8 complete laps. So for that we need to first find the distance, total distance for one lap. So to find the distance for one lap, we'll just multiply 8 times quarter mile, will give you 2 mile. So the total distance of one lap is, now let's say, no, total distance for one lap is quarter mile. Now we need to find total distance for 8 laps. So this is the total distance covered by the 8 laps. Now we will convert these miles into centimeter. No, meter. 2 miles is equal to how many meters? So 2 miles is equal to 3218.68 meters. So you can find the conversion rate anywhere. So yes, 1 mile equal to 160.34 meter. So 2 miles is equal to 2 times this value, will give you total meters. Now we have total time distance, and we'll need total seconds. So we'll convert this 12.5 minutes, which is taken from the question, into seconds. When you convert this into the seconds, you will get 570 seconds. So average speed equal to total distance upon total time taken by the object or anything. So 3218.68 divided by 750 will give you 4.29 meter per second. That's our answer, 4.29, which is C. Let's move on next question. A car of mass m traveling with the velocity v strikes a parked station wagon whose mass is 2 meter. There is some mistake with this question. The bumper locks together. This is head-on collision. What is the fraction of the initial kinetic energy in the lost in the collision? So we know that our equation, which is, yes, m1v1r plus m2v2 is equal to before the collision and after the collision. So we'll use the same equation. m1v1 plus m2v2 before the collision is equal to m1v1 plus m2v2 after the collision. So in this case, mass of our second object, which is the wagon at rest, is 2m. Okay, yeah, that's not 2 meter, that's 2m. So this will be 2m and this will be just m. before the collision and after the collision. Same, this will be 2m, this will be just m. So our initial velocity is 0 because our second wagon is at rest before the collision, and after the collision this both car will combine together, so this v1 and v2 will become vf. So now we have mv plus 2m times 0 is equal to m plus 2m times vf. This is 0 because initial velocity of wagon is 0. Now vf is equal to v by 3. You just need to rearrange this equation. Now kinetic energy is equal to half mv square. Now our v is this and our m is m plus 2m. Let's substitute all the value. Half plus m plus 2m times v by 3 whole square. Now you again do some math, then you will find the final equation 1 by 6 mv square. It's like this will become 3m, so half 3m v by 9, v square by 9. So this will become this. And yes, you will get this final equation. Now energy loss equal to kinetic energy initial minus kinetic energy final. So our initial kinetic energy is half mv square. Our final is 1 by 6 mv square. Now in this case you can take common mv from both sides, so you just need to minus 1 half by 1 by 6, then you will get 1 by 3 mv square. So this is your answer, 1 by 3 times. What fraction of initial kinetic energy is lost in the collision? So 1 by 3 times, which is 1 by 3 times. Alright, let's move on next question. A 15 kg box is released on 32-degree incline and accelerates down the incline at 0.3 meter per second. What is the friction force impeding its motion? So the force acting on this box will be given by F parallel is equal to mg sine theta. Now why sine theta? Because we are taking y component of the force. So our m is 15, g is 9.8, sine 32, and now When you calculate this, you will get 77.9 Newton. Now we also know that F net is equal to m times A. So our m is 15 times A is 0.3 will give you 4.5 Newton. So our F net is 4.9 Newton and F parallel is 77.9 Newton. So this is F parallel in this direction. This is normal and this is gravity, force due to gravity. And friction force will be acting on this direction. Now why this F parallel will be sine theta? Because it looks like it is in the x direction, right? But no, when you see this and when you rotate this in the particular direction in this way, then this would be the x and this would be the y component. So this component will be taken as a y component. So now we know F net and the F parallel. So F friction is equal to F parallel minus F net. So 77.9 minus 4.5 is 73.4 Newton. This is our answer. B. Let's move on next question. A small 650-gram ball on the end of the thin string is rotated in the horizontal circular with a radius of 1.2 meter. What is the moment of inertia of the ball about its center of the circle? Ignore the string's moment of inertia and air resistance. So this is the equation to find moment of inertia, m times r square. So we just need to substitute our value. Our m is 650 gram, so we have to convert it into the kg, 0.650 gram kg times 1.2 meter whole square. It will give you 0.936 kg meter square. This is our answer. A. Let's move on to the next question. A police car has a 800 Hz silence. It's traveling with this speed. On the day when the speed of sound through air is this. So let's say there is some day when speed of sound in air will be this, not this. The car approaches and passes an observer who is standing along the roadside. What change of frequency does the observer hear? So car is traveling in this direction. Let's say now observer is standing here on the roadside, not in the middle. This is the roadside, and police car came and passed through just next from the observer. Now they want us to find the change in frequency the observer observed. So for that, we have one equation: f dash is equal to f0 times v plus v0 divided by v minus v0. Now f0 is the frequency of the source or the moving object, so it is given in the equation as 800 hertz, and v is the velocity of the sound in air, just v, and v0 is the speed of the object, which is 35. So we'll substitute all the values and then we'll find the frequency. But when car is approaching towards the observer, so it is moving towards, our equation will become v upon v minus v0, and when it's moving away, f0 times v upon v plus v0. So we'll use these equations and substitute our value. Let's find this. When the card is moving towards the observer, we'll use this equation. We substitute all the values which given in the question. This is the speed of the car, speed of sound, frequency of the siren of the car. So when you calculate this, you will get 891.8 hertz. Similarly, we'll do the same calculation for the car when it's moving away, but we just need to change this sign, and when you put this all in the calculator, you will get 75.3 hertz. Now change in frequency is equal to frequency when object is moving towards the observer minus frequency when it's moving away. 891.8 minus 725.3 will give you 166.5 hertz. This is answer, hertz. This is the answer. Let's move on next question. A constant pressure gas thermometer is initially at this degree Celsius. If the volume of gas increases by 10%, what is the final degree Celsius? So we'll use this equation: V1 upon T1 is equal to V2 upon T2. So T1 is equal to T2 times V1 upon V2. T1 will be 28 degrees Celsius plus 273.15, because you have to convert it into the Kelvin. All the Celsius stuff you have to convert it into the Kelvin. V2 is equal to V1 plus 0.1 V1 will be 1.1 v1, where change in volume is equal to 10%. v2 minus v1 is equal to 10%, so it is nothing but 0.1. v2 minus v1 is equal to 100. This will be 0.1, and this way v2 is equal to 1.1 v1. Now let's substitute all the equation in our above equation. So v1 upon t1 is equal to v2 upon t2. v1 is v1, t1 is 301.15 is equal to 1.1 times v2 v1 upon t2. t2 is equal to 1.1 into 3.301.15 will give you 331.27 Kelvin. That's our answer. Oh, you need to convert this into the Celsius. So when you convert this into the Celsius, you will get 58.12 Celsius. Answer is B. Let's move on to the next question. Real quick. What is the length of an open organic pipe that emits middle C, its frequency when the temperature is this? So we know that F is equal to V upon 2L. The velocity of sound in air can be approximately given by V is equal to 331.4 times 0.0 t. They want us to find what is the length of an open organic pipe that emits frequency when temperature is this. So when you want to find the sound of the speed of sound with change in temperature. Then this is the equation 331 plus 0.16 times temperature. So let's say temperature is 40 degree and you want to find the speed of sound when temperature is 40 degree. Then you just have to use this as instead of t. So in this case we need to find v when the temperature is 21 degrees Celsius. So 331 plus 0.16 times 21 will give you 344 meter per second. Now, this equation is general and it's fixed. Lambda is equal to v times f. Our v is 344. Our f is 262. Will give you 1.313 meter. Now we know our wavelength, and now they want us to find the length. So L is equal to lambda by 2 for open pipe. So we know our lambda 1.313 upon 2 will give you 0.0656 meter. That's our answer. 0.0656 meter D. Let's move on next question. A jumper in the long jump goes into the jump with the speed of this. So this is our initial speed with angle of this. Angle with the x-axis above the horizontal. So yeah, they say this is the angle with the respect to x-axis. How far does the jumper jumps? So they want us to find the total distance covered by the jumper. So for that we know the x component of the velocity is v0 cos theta. The y component will be v0 sin theta. Now we need to add those values from the questions. 12 times sine 20. So x component is equal to 11.28 meter per second. Y component of the jumper is 4.10 meter per second. Now time of flight, like how much time the total flight it takes. So v of y component upon gravity will give you the total time taken by the flight. So this is our value of the y component and this is gravity. Total time taken by the jumper is 0.4 seconds. So this equation will give you the time taken for the jumper for its maximum height, to reach its maximum height. Now we need to multiply this by 2 because we need to find total time. So yes, this is not the total time taken by the jumper to cover all the distance, but this is the half time. Why half time? Because this is the time taken by the jumper for the maximum height, v component. Now when we multiply this by 2, we will get the total time covered by the jumper, which is 0.836 seconds. Now we have second, we know speed. We can just say distance is equal to speed times times speed is around 12 meter. Our time is 0.836 will give you 9.43 meter. So answer is C, option C. Let's move on next question. What is the gravitational force on 50 kg person standing on earth due to the moon? So someone is standing on the earth. It has 70 kg of mass. Now moon, so it looks like earth. Now moon, gravitational force of moon will pull this person towards it. Now they want us to find the gravitational force by the moon on the person standing on the earth. So F is equal to G times M1 M2 R square. The mass of the moon is given in the question and the distance is given in the question, which is R. Gravitational constant is given in the question. Ignore the variation of gravity due to the location of the person on earth. That's random stuff. We just need to use this formula. 6.67 into 10 raised to minus 11 times 70 times 7.3, 22 kg. Mass of moon, mass of person, mass of person, mass of moon, whole divided by R square. Total distance between the person and the moon. When you put this whole stuff in the calculator, it will give you some value, which should be equal to 0.00224 Newton. Now this much force person is feeling while standing on the earth because of moon, in the direction of moon. So our answer is 0.0024 D. A force moves an object in the direction of the force. The graph shows the force versus object's position. Find the work done when the object moves from 2 to 4 meter. 2 to 4. So work done is equal to force times distance. So W is equal to Fd. So total force acting on the object is 2 Newton or 20 Newton during this area or during this period, and total distance will be 4 minus 2, which is final minus initial, will give you total distance. So 20 into final minus initial, 40 joule. That's your answer. 300 gram mass vibrates across according to the equation. So according to this equation, the mass is vibrating, this much mass is vibrating according to this equation, where x is a meter, t is a time, what is the period of the vibration. So this is the general function of sinusoidal function. This is the general sinusoidal function. This is omega t, not wt. Omega is angular velocity, will be 4 pi. Now time period is equal to t is equal to 2 pi by angular velocity. So we know our omega. Now this is our equation given in the question. So omega is equal to 4 pi, t is equal to t, and a is equal to this value. So from this, omega is equal to 4 pi, and this is the general equation for the time period, 2 pi upon omega, and omega is equal to 4 pi. So 2 pi upon 4 pi. So time period will be half, 0.5 seconds. C is the answer. So this much heat is equivalent to how much work done. So work is equal to, let's say, 1 kilocalorie is equal to 4184 joule. So work is equal to 16.5 calorie times 4184 will give you 69156 joule. 69156 joule. It should be equal to this. So B is the answer. D is the answer. $50 grams of iron at 100 degree is put into the 75 grams of water at 0 degree. What is the final temperature of the mixture? So red hot iron is put into the water with 0 degree Celsius. Now what is the final temperature of the mixture? So in order to find this answer, we need to find the heat loss by iron. So heat loss by iron, let's say Q is the heat loss by iron, so is equal to mass of iron is equal to Fe. So mass of iron times what's the specific heat of iron times T initial minus T final. Same way, heat gain by water, mass of water specific heat of water final minus initial. temperature final minus initial. Now our heat is transferred from the iron rod to water, so we can say that this equal to this. So our equation would be this equal to this. Now we'll substitute all the values. Specific heat of iron is given and specific heat of water will be okay, so they didn't give the specific heat of water, so it will be 4184 joule per kg degree Celsius. So we substitute all the values from the equation. Mass times specific heat times initial minus final is equal to mass times 4 point specific heat times final minus initial. Now multiplying these values multiplying these values and these values, you will get something. This is equal to 313.8 times T final. Now doing some rearrangement, you will get T final is equal to 6.69 degrees Celsius. This is our answer, 6.69 B. And this is our last question. Question number 70. How much heat need to be removed from 100 gram of this much degree Celsius of water to make it -5? Okay, so how much heat you need to remove in order to make the temperature of water from -5 degrees Celsius? So for that we'll use the equation of the heat loss, mass times specific heat of water times change in temperature. So change in temperature is always final minus initial. So delta T is equal to 80 minus 0, which is 85 degrees Celsius. So let's substitute all the values. Now this much energy should be taken out for the water when you want to make the temperature from 85 to 0, and then we have to do work for 0 to -5 degrees Celsius. So this much energy is required to taken out from the water, and for this we have to find So this should be the Q2 and this should be the Q1. Q1 and Q2. So Q1 amount of energy is required to decrease the temperature from 85 to 0, and Q2 is required from 0 to -5. M times LF. What is LF? This is latent heat of fusion for water, and that's a mass. M is mass, 0.1 kg times 80. So this value is fixed latent heat of fusion for water. So this should be the Q3, and when water get fused from the liquid state to gas state, so is Q2, where water get converted from the liquid state to the solid state, not gas state. Now Q3 will be the energy required to remove the total heat from 0 to -5 degrees Celsius. So Q3 will be M times latent heat, specific heat, times change in temperature. Delta T will be 0 minus -5, then it just 5 degrees Celsius. Point 0.1 times 0.5 times 5 will give you 0.25. Now total energy required to convert water from 85 degrees Celsius to -5 degrees Celsius. So you need to add Q1 plus Q2 plus Q3. Now you add all the Q1, Q2 and Q3, then you will get 16.75 Kelvin. So that's our answer. 16.75. D is answer. So these are all the numerical question solutions from 31 to 70. So all the numerical questions from the sample final test PDF. Questions are given with all the solutions and explanation, so you can correlate with the question paper. So yes, this is the sample final test PDF.